Okay, welcome to the lecture number 7, and today we have got some idea of the three elements RLC. They will be now connected in certain fashion, series, parallel, whatnot, and they will be excited with some source, maybe voltage source, current source, etc. And we would like to find out the response. That is, if voltages are known, then what should be the currents when you do some switching, or vice versa. Okay, but before that, just one point about the capacitor. And we have seen that the voltage across the plate of the capacitor is equal to V0 minus plus 0 plus 2t into IT dt, and this is 1 over C. This is we have seen. Therefore, if you have a capacitor which has got some initial voltage attached to it, these two things prompts me to so here is the capacitor, C, and I say that it has got some initial voltage across the plate of the capacitor whose value is known, plus minus, and this is the capacitor where I am exciting it with some current IT. I have injected a current IT into the circuit at t equal to 0. Then this is how I should do it. So this equation prompts me. And what is this? This voltage across the plate of the capacitor is Vt. Now imagine this capacitor is connected in some circuit as an element, separate element. That circuit might have different other components present, including various kinds of sources. But the point is, and suppose these two terminals of the capacitor is A and B, ideal capacitor. So between A and B, I can say that it can be represented by a uncharged capacitor of same value as C. This C is uncharged capacitor. In series with another voltage, which will be plus minus V0 minus, and then A and B. In case of inductor, I have elaborated this point. Inductor, if that inductor had some initial current I0 minus, you can live with this circuit as it is. But if you have some initial current in the inductor, then that can be represented. We did this, an uncharged inductor in parallel with a current source. These are new things, new way of thinking. Uncharged inductor. So here it is uncharged capacitor, uncharged C. Therefore, you can always convert a energy storing element in its equivalent form, provided it helps you to analyze the circuit. You must be careful about that. But this way also I could think that okay, there was a fixed battery voltage plus minus, so that the voltage across the plates of the capacitor, actual capacitor, will become plus minus Vt. Got the point? This point I just wanted to ask you to recall. So dualities, so in case of inductor, initial current can be represented as a current source in parallel with the uncharged inductor. And similarly, a capacitor initially charged can be represented by this way. and this is the direction of the current. Mind you, this voltage and this voltage are not same. Total voltage is Vt. You should be careful about that. Anyway, think about it. Achha, now today I am going to do some transient analysis for some known results that I will do very quickly, but you please follow me. It is so interesting. For example, one problem all of us do at our undergraduate level is like this: an RL circuit, and here is a switch, and here is a battery voltage E. I will close the switch at t equal to 0. This switch will be closed, and this battery voltage is known to be, say, E. I want to find out the current in the circuit. I told you, you should not apply a constant voltage. No, this is fine. E, IT, it goes like this. Acha. So, and I say that I0 minus was 0 because the switch was open, no current existed earlier. So, I0 minus was 0. The question is, what is the expression of IT? That is the thing. Now, to find out that, what you should do is this. The way you have assumed the direction of the current, it is totally your prerogative. The way you have assumed, then I will say the voltage existing across R is R into I, and voltage between these 2 points across a pure inductor, current is IT, is L di dt. It has to be true. That is why it is so important. Draw a circuit. The moment you want to write down the Kvl equation, you assume the currents, directions. That is your wish in which direction you will assume. It does not matter. But once you assume that direction of the current, don't play with these polarities. I know individually, I told you earlier, this is how it is to be written. Then what you do, you write down the Kvl equation. Kvl equation in this circuit. So Kvl equation, you start from this point and try to start your journey from this point. Suppose you go like this. So from this to this, there is a voltage rise which is constant E. Then from this to this, there is a voltage drop, plus to minus Ri. Then once again plus to minus L di dt. And you have reached this point, assuming the connecting wires has got no resistance, etc. So this point is same as this point, no drop here, and you have reached this point. So I started my journey in this direction, and KVL says that Kirchhoff's voltage law, this must be 0. So you see that this equation can be written as L di dt plus Ri is equal to E. E is a constant fixed number, okay? And I have to find out the value of. It is always preferable you normalize the coefficient of this di dt term to 1 so that it becomes R by L into I is equal to E by L. This is the equation. It is a first order linear differential equation with constant coefficients. Coefficient of di dt term is 1, coefficient of I is R by L, which are constants. E by L on the right hand side is a constant. So this is the solution. So you see that and it is called a first order system, first order. order of the highest order of the differential will decide di dt, first order, second order d2i dt2, like that. So it is a first order linear differential equation. You can solve it in many ways, and the final result is also known, so popular a result it is. But in any case, as I told you, this voltage, which I have assumed to be a constant battery voltage, that means it does not change with time. Therefore, it is a very special case. In general, this applied voltage could be any function of time. Got the point? Vt could be any crazy type of supply voltage waveform, and a descent waveforms could be a sine wave which is varying with time, things like that. Or it could be a single pulse which will exist. You are feeding then this RL circuit from a signal generator, as I was telling to you. So in case of resistive circuit, when all the elements are purely resistances, you switch on any voltage, either time varying or constant voltage, the shape of the currents will be also similar to that applied voltage. Isn't it? We have seen that. And there is no, so the resulting KVL equations will be linear algebraic equations. Mesh analysis, this, that, you write down, etc. Whatever you do, you will always get no differential equation you will expect there. But the moment there is some energy storing elements present in a circuit, the KVL equation will become a differential equation. And therefore, you have to solve for, what is the question? Question is, what is an IT for t greater than equal to 0? You want to solve for the current in the circuit. Is not that? Now, therefore, it looks like I have to solve a differential equation. A few words about the solution of differential equations, which will be mostly used in electrical engineering and elsewhere, I suppose. There is, so that thing, let me understand. For example, I say that, so solution of differential equation. Very quickly I will go. You know that, but with some maybe some new ideas, you just see how it can be solved. For example, I say that I have a differential equation which is dy dt plus first order differential equation y. Y is a function of time and the input is xt. In our case, it could be a voltage waveform, y could be the current waveform, or vice versa, whatever it is. So all of them are time varying. You are going to solve for y, okay, and xt is your forcing function or the input function, forcing function. Clear? It will be like that. Acha, when this equation comes into, when I have to deal with such an equation, example is this one. Okay, energy storing elements is there. This is the equation, di dt plus ai, some constant into I, is equal to some forcing function because it depends on E. Isn't it? This L I have brought in because I prefer to divide the coefficient of this highest order differential term. I would like to make 1. But nonetheless, this one I can treat it as your forcing function, which is constant, very simple case. But in general, what I am telling, this right hand side could also be a function of time, and you have to find out the solution. Now, this solution of this one, whatever it will be, first let me write it. It will comprise of two terms, ynt plus yft. The solution of this differential equation will consist of two terms. One is called natural response and natural response of the system, and this is called response due to forcing function. Response due to forcing function. Always think in this way. Okay, differential equation. Now the question is, what is natural response? Natural response is, if you solve this differential equation with forcing function 0, whatever solution you will get out of it is called natural response. Got the point? That is, with forcing function removed, differential equation will look like this. Natural response you will get by solving this ynt when xt, there is no forcing function present. Then the equation will look like that, and then you solve for it. Now the question is, if there is no forcing function, how can there be a response? It is not a surprise that there will be response, because you have energy storing elements present in the circuit. Although this voltage you make 0, your forcing function 0 means this is 0, shorted. No shorted. Now, can there exist any current in the circuit? Yes, there can, because inductor might have stored some initial energy, half Li square, and that energy finds a nice path to be dissipated in this R, and during that process current will flow, and so these two terminals where I am connecting the input, here in this case a plus E or general xt, therefore a differential equation results while describing a system all the time, provided there is some energy storing elements. Therefore, natural response, what I am telling here is when xt is 0, and I should have no doubt about that. Okay, there may be a system response. Even when xt is 0, y may change with time. Why? Because of the initial energy stored or initial conditions present on y. That is the thing. Then there may be a situation like that. Okay, so this is the thing. So let us try to first, so I have to solve this one and this one, then add this together to get the total solution. So this is the total solution, I total. That is what my goal is. Now, so I have been asked to solve this first order differential equation to obtain the y and t with right hand side 0. So I feel okay, fine, things are simplified. Now there are various ways you can solve it. You can, in this particular case, multiply with integrating factor, this, that. You can do several ways. But I will ask you to think it in this way, so that your thought process is most important. Okay, here is the differential equation. A is constant and I am looking for yt which will satisfy this equation. Is not? That is the problem at hand. Okay, can I guess the solution? For example, the solution of this equation, can it be sine omega t? No. Why it cannot be? Suppose y is equal to some sine omega t, because it looks like it will be a wild guess. No one knows. But suppose, for argument's sake, somebody says, no, the solution of this equation will be some sine omega t type of thing. I will immediately say that, look here, then that whatever solution you are claiming, that must satisfy this equation. So you will get sine omega t here and you will get cos omega t there, and adding some sine omega t and cos omega t and getting 0 for all time t, not possible. No. For example, somebody says x t is equal to t square, y nt is t square. Then also I will say, it is t square and it is t. Can you, for all time, adding t square and 2t functions, make it 0? No, you cannot. But although it looks like it is a sort of impossible task, I mean, how one can go on guessing and trying to find out solution. But you see, do you know any function which, if you differentiate, will not change its form? Yes, those function is known to me, known to you also. And some of you already have answered it, although I cannot communicate with you directly. But you know, why, if it is some e to the power at function, I mean some exponential function, I do not know whether it will be at or not. Suppose it is e to the power minus at function, some constant, let us guess the function. You see, if the solution is exponential type, then y is exponential, dy dt also will have exponential, because this constant term will come outside, it will remain exponential. And these two exponentials can conspire when you add them and give you 0, fine. Similar type of waveforms, subtract, add, they may give rise to 0 all the time. Got the point? So that is where the key lies here. That is, you are guessing it, but guess is not wild, which looked earlier sort of impossibility. No. It will be a function of time. It will be a function of time. Two functions of time. I am adding and expecting to give me 0 for all time t. That is very important. Can only happen if the nature of the function y and dy dt are of the same form. Then they can cancel each other with some thing. Is not? That is the whole idea. Okay. So how to proceed then? Let, and mind you, this is natural response 0. Y and t, let us assume it is equal to some constant a into e to the power mt, because exponential function will do, there may be some constant a also involved. A and m are constant. So if this is to be a solution, put this solution there and try to get the values of a and m, how they will look like. So dy dt, it will be equal to a m e to the power mt plus a y, that is a e to the power mt, and that must be 0 for all time t. For all time t is very important. You can find always some functions which may not be exponential. At t equal to 5, they may cancel each other and give you 0. But we are not interested in that. It should do it for all time. That is very important. Therefore, this is the thing. Or this equation tells me that this is equal to m plus a and into a into e to the power mt. That must be then 0. It tells me that a into e to the power mt, take outside and it will be 0. This in fact is the solution int, is not in this equation. Int, I have assumed it to be this. And this solution I am telling is not 0. Then if it is 0, there is no natural response solution. Therefore, this fellow must be 0. It is not equal to 0, this term. So, m plus a must be equal to 0. And we say that m equal to minus a. This is the thing. So, we are going through the natural response of the system, and we find that it must be exponential. Nothing other than exponential can really solve your circuit. So, let us take some other pages. So what we gathered? We gathered very important thing. Our starting point was dy dt plus some a is a constant. This was the system equation, and right hand side was 0. Therefore, it will give you int. That is what I am looking for. And then I discovered that nt must be exponential in nature. It cannot be other than that. And I assumed the solution to be a to the power mt, where m and a are unknown, but they are constant. If you differentiate, and finally you got m plus a is equal to 0. This equation is called characteristic equation of the system. This is called the characteristic equation of the system. What is the value of m? M is minus a. M is minus a. Then I will say, look here, int will be some constant capital A into e to the power minus at, where a is the system coefficient associated with y. You know, this is the thing. Very interesting. Okay. And what about capital A? Capital A should be also, see, small a is known, coefficient of that term. Okay, we will find out that also. Unless I find out that, what is the total solution? Anyway, this is int. This solution, I am telling you, if you substitute it here, you can easily see it will cancel. If you put it blindly on the left hand side, it is bound to give you 0 all the time. Clear? Therefore, we have found out the solution due to natural response. And mind you, the natural response, whatever time functions you are getting, that will always satisfy, that is left hand side, when you substitute int, will always give rise to 0. Okay, but we have another thing to be found out, which is called solution due to forcing function. Clear? Now, solution due to forcing function. due to forcing function. What is this? I have to find out dy dt. This was my equation, but right hand side it is not now 0, xt. This is my forcing function. How to find out this? I have uploaded a load, I will upload in fact, but for the time being what I am telling it, take it for granted that the solution due to forcing function will be yft will be the end result I am telling, which is so easy to remember. It will be a linear combination of the forcing function and its higher order derivatives, and will generally have infinite term. What does it mean? It means what I am telling is the solution due to forcing function will be k1, the forcing function, plus linear combination of its next higher order derivative, plus k3 x double dot plus k4. If you write it like this, it does not matter. Okay, k3 k4 x triple dot, x double dot means d2x dt2, x triple dot, you know that. So go on doing like this up to infinity. That will be the solution due to forcing function. Without any proof, I have told you. Take it for granted. I can carry on, but it will become mathematics class. But in the note, I have told how this result is obtained. But why this final result I am writing in this fashion? To tell you that, okay, the solution of this equation will have a natural response. That is very easy to find out. Find out the characteristic root and get that. And the solution due to forcing function is also easy to remember. It will be some constant into the forcing function itself, xt, plus k2 into dx dt, plus k3 into d2x dt2, plus k4 into d3x dt3, up to infinity. All linear combinations of the forcing function and its higher order derivatives. This is the usual way of looking at the solution. Therefore, I will say that solution of this equation will be solution due to its natural response plus solution due to forcing function. And this will be, we have already seen, this one is a to the power e to the power minus at, and plus this term. Because the solution due to forcing function will depend upon the forcing function and its higher order derivatives. So this is your yft, this is your ynt. So natural response depends upon its characteristic equation root. And the characteristic equation, how to write it? It is like this. You consider d dt to be your m. So m plus a. Replace d dt by m, and why you forget m plus a equal to 0 is the characteristic equation. That is what I am telling. This equation can be written as d dt, this operator, plus a into y is equal to 0. Natural response I want to find out, xt is 0. So d dt replaced by m, and you will get that. You need not start writing, okay, gas e to the power at, put it there, then show that m plus a is the characteristic equation. Easier way of doing it, write it in this fashion, natural response. So why I expect something, it is not 0. So treat this d dt to be replaced by some m, some number, and m equal to minus a. And then say a into e to the power mt is your solution. Natural response. So that's it. Therefore, writing down the solution of a differential equation, at least, and it is true for first order, second order, anything. I mean, you can easily verify that. But the point I want to stress upon is that if I know the differential equation, nature of the total solution can be written in one stroke. You will learn later some sophisticated techniques like Laplace transform, Fourier transform, etc. to solve differential equation. But also this is called classical way of solving differential equation, where you need not go to Laplace transform of things like that. Of course, the end results will be same. But here, the solution can be written by inspection, straight. Got the point? So this is total solution. Only one point you note here, that if this total solution, if you substitute in this differential equation, what will be the natural response? Natural response part of these two terms will add up to 0. So this, if I do, I conclude that another important conclusion, dyf dt plus ayf must be equal to xt, because it was actually yf plus yn. So dyn dt plus ayn, that result is known to be 0. So this will be the situation. In other words, what I am telling is this: forcing function alone, solution due to forcing function due to forcing function alone satisfies the differential equation. This is the thing. Got the point? So this is the thing. Now, if this solution due to forcing function separately can be found out and things. Let us now come back to our original problem, today's problem, which we started like this. Some RL circuit I was telling. So I now apply these techniques and how simple it becomes, you see. See, it is like this. So your RL circuit quickly, and after this I will stop today. And here is your forcing function, which is constant in this case, E. This is R, this is L. I want to find out IT when S is closed at t equal to 0, and it is given that I0 minus equal to 0, boundary condition. So what I did, mind you, after the assumption, this step you don't forget, with polarity, show the voltages appearing across each element. Supply voltage polarity is also an element, source element whose polarity is also to be given, and this polarity LDI dt. And we write down the KVL equation, we get LDI dt. Let me repeat that so that you don't miss any point, and this is equal to E. That is what we did. Then I say that di dt, you make this, it is not absolutely necessary, but I do like that. It is helpful in some other cases as well, you see. So normalize this coefficient to 1 by dividing L. Now this forcing, can I write down the solution straight away? Total solution. Yes, I can. Characteristic equation is m plus r by L is equal to 0. Is not? D dt you replace by m. So this equation can be written as d dt plus r by L, and whole things will operate on I and give you 0, then only characteristic equation you get. D dt you consider to be m, some m plus r by L is 0, m is minus r by L. So the solution will be a e to the power minus r by L into t. First part is done. A is still unknown. Okay. Then solution due to forcing function. What it will be? Solution due to forcing function will be some constant k1. Mind you, this is your xft, solution due to forcing function. So xt, this is your xt input, which is constant in this particular case. So it will be k1 into E by L, whatever it is not? Plus k2 into the first derivative of this constant number, which is 0, plus k3 second derivative, all derivatives will be 0. So although it looked to be quite a heavy task to sum the infinite number of terms of higher and higher order derivatives, in most of the cases, for example, if it is constant, only the first term exists. So here ends the matter. This is the solution. This is the total solution. You will get it is equal to a into e to the power minus r by lt and k1. So nature of the solution is immediately known. See, all these steps essentially becomes very simple at the end. By inspection, I will write down the solution. Characteristic equation that will decide the natural response, and k1 into forcing function plus k2 into its higher derivatives, that will give you the solution due to forcing function. Mind you, now this condition is to be satisfied. What is the condition? Boundary condition given is I0 minus equal to 0, is not? And that I have to apply on the total solution, mind you. Don't separately try to apply. So if I0 minus equal to 0, so it will be equal to 0. Put this boundary condition now. And this applied voltage is no impulse. So I0 minus and I0 plus are one and the same, which is equal to I0. So put t equal to 0 and you will get A plus K1 into E by L. That is equation 1. You see, there are two constants, A and K1. Is not? Okay. And both of them are to be found out to get the total solution. Okay, how do I get the another equation? Where from to search? Another equation you will get from this knowledge that forcing function alone also satisfies this differential equation. Isn't it? What is the solution due to forcing function? It is this part. This alone will also satisfy this differential equation. This is the crucial. That's why I told you that the importance of this state. The solution due to forcing function alone, this is alone satisfies the differential equation. Therefore, if that be the case, then I will say K1 E by L, which is solution due to forcing function, alone satisfies the system equation, differential equation. That is this equation. It will satisfy this equation. So put that. So di dt, that is IFT, solution due to forcing function. IFT is how much? IFT ddt of a constant number is 0 plus R by L, isn't it? R by L into the solution K1 E by L, and that is equal to E by L, because right hand side is E by L. Forcing function alone satisfies this. Hopefully I am doing okay. Anyway, if I have done any mistake, result will not come. Let us proceed. So this will be the thing. IFT, forcing function alone satisfies this, di dt is 0, and R by L K1 into E by L. So E by L cancels, and K1 you get L by R. That is the thing. Then I will say that K1 being known, or L by R, I will come back. So this is equation 2, from which, so K1, K2, etc. are to be found out by what is called, because it is an identity, so from that you can find out. So in this case it was so obvious. So it was written like this. Then I will write 0 is equal to K1, second equation is K1 equal to L by R. And then from first equation I will say A is equal to minus K1 E by L, and to put this value it will become minus K1. K1 is L by L. So K1, why I am doing all these things? K1 I have got. So put this value of K1 here. It will be equal to A plus K1 is L by R into E by L. LL cancels out. That is equal to 0. Therefore, A is equal to minus E by R. And then the solution will be, total solution will be Y, in this case IT, current expression then will become capital A is minus E by R, so minus E by R I put, and e to the power minus R by L into T plus K1 is L by R into E by L. And you get that famous relationships 1 minus e to the power minus r by L into t. I mean, see, first order differential equations, you know how to solve it with constant coefficients. But what I am telling you is that you try to write down the solution by inspection and arguing like this instead of doing several mathematical steps, integrating, differentiating. Okay, solution of a first order differential equation will be consisting of two parts: natural response, which depends upon characteristic root, and the shape of the solution you will be able to find out as the characteristic root c to the power minus of that plus k1x plus k2x dot. That is the usual way, and in most of the cases this solution will become simplified to this. So anyway, I stop here today and we will continue, and I want to guide your thought process in this way to visualize any physical systems. Differential equation you have written. Okay, there may be a natural response. Can natural response be there with right hand side 0? Yes. Since the system is described by a differential equation, you may be rest assured that there must be some energy storing elements in it. And with initial condition in those energy storing elements will give you some response of the system even if your input is not present. Okay? And then what about the solution of the forcing function? Very simple. Only solution due to forcing function is it will be a linear combination of the forcing function and its higher order derivatives. That's it. Anyway, I stop here. I think I have talked too much to tackle these rather simple problems, it looks like. But this will pave the way to proceed further with higher order differential equations as well. Thank you.